All right, look, check this out. January 1st, 1804, Haitian Independence Day. So every year on January 1st, Haitian independence is recognized. I got my Haitian Revolution t-shirt on, my condo, Boukman Duddy, Toussaint Louverture, and my guy, Jean-Jacques Dessalines, right? So shout out to the Haitians that fought in the Haitian Revolution on Saint Domingue from 1791 to year 1804. If you're not too familiar with that revolution, please go do your research on that. Check out the Black Jacobins, not the Last Jacobins, the Black Jacobins by C.L.R. James, a Trinidadian brother and historian. The Irritated Genie by Jacob Carruthers. There's a handful of other books whose names escape me right now, so forgive me. But once you start doing your research and go down that rabbit hole, you're gonna come in contact with them. All right. So again, happy Haitian Independence Day, January 1st. Now we about to solve a system of equations. A system of equations. Also, make sure you subscribe to the All This Math YouTube channel. Make sure you subscribe. All right. Make sure you like the video. If you like the video, drop a comment down below too. All right, and share this video with some other people. All right. This is called a system of equations because there's more than one equation. All right. We got one equation. We got two equations. We also got more than one variable. We got an X and a Y. We got an X and a Y, right? We about to figure out what both of those values are, right? So what values of X and Y make this a true statement? What values of X and Y make this a true statement? We're about to do both of those. Now, when you solve systems of equations, it's typically three popular methods. There's the graphing method, right? Where you can graph this as a line, right? And then graph this as a line and see where they intersect or if they intersect. Sometimes they might not intersect. We're not about to do that though. There's the substitution method, right? Where we essentially solve for one of the variables, either X or Y. And when I say solve, I don't mean we find the numerical value. We just find an expression that is equal to, right? And then we take that expression and then substitute it into the other equation. We're not about to do that right now neither. We're about to use what's called the elimination method. Some books call it the elimination method. Some other books call it the addition method. Some other books might call it some other things, but as when I came up, it was called either the elimination method or the addition method because what we're doing is, and again, everything in math is called what it's called for a reason. Because one of the things we do is we pick a variable to eliminate, meaning to get rid of. All right, so that way we only end up with one variable. And if we have one variable, we can solve for that one variable in one equation. All right, it's also called the addition method because what you do is you basically add this equation to this equation. All right. Just like the standard algorithm for addition that we learned in elementary school. We add the top equation to the bottom equation. So since we're using the elimination method, we got to eliminate one of the variables. So what you got to do is when you see a problem like this, you got to decide what variable do you want to eliminate. Do you want to eliminate the X? Do you want to eliminate the Y? Now, in this particular problem, it really don't matter. Eliminating one is not necessarily that much easier than eliminating the other. What I might do is I probably eliminate the Y's. Because the way you eliminate is like this. Since you're going to end up adding the equations to each other, the top to the bottom, the coefficients of the variable you want to eliminate got to be opposite. I'm going to say that again. The coefficients, what's a coefficient? This 3 right here is a coefficient, 3y. It tells you how many y's you got. This 4 right here tells you how many x's you got. This invisible 1, which makes this -1. This -1 is the coefficient of this y. This invisible 1 up here, that's the coefficient of this x. Make sure you know what a coefficient is. For real, you need to know what a coefficient is. I just broke it down for you. It's the number that's attached to the variable that tells you how many of that variable you got. All right. So when you eliminate in a variable, you want to make sure the coefficients are opposite of each other. Right. So when you add them, what's going to happen? They're going to cancel out. Right. Like 10 minus 10 is 0. Well, 10 plus -10 is 0. 100 plus -100 is 0. 50 plus -50 is 0. They cancel out. Right now, if I want to eliminate the y's, this needs to be a -3y. This needs to be a -3y because I already got a +3y. I need to make this a -3y, right? So +3 and -3 added together gives you 0, nothing, nada, nothing, right? So the question is, how do I change this into a -3y? You do it like this. You multiply this whole equation by +3. It's like a puzzle. It's like a game. All right. See, math not hard. This is a bunch of games. All it is, bunch of games. Multiply this whole equation by 3. Now, not just that, because you got to change everything by a factor of 3. All right. Like basically you're increasing the size of the equation by a factor of 3, just like on your phone when you zoom in on a pic, you're making it bigger, right? Everything got to get bigger. right? The 6 got to get bigger. The negative y got to get bigger. The 4x got to get bigger. So that way you keep everything, keep the value the same, right? But you're just enhancing it by 3. So what's going to happen is I'm going to rewrite the system. The top equation don't change. Some problems you're going to have to change both equations. But in this case, the top equation or the first equation don't change. So I'm going to just rewrite that. X plus 3y equals 8. At the bottom, I distribute the 3. I multiply 3 by everything in that second equation. Everything. So I do 3 times 4x. That gives me 12x. I do 3 times negative y. That gives me negative 3y or minus 3y. Minus 3y, negative 3y. Minus 3y, negative 3y. They basically mean the same thing. And I do 3 times 6, 18. Don't forget to do the 3 times 6. A lot of people forget to do the 3 times the constant. Sometimes I make that mistake. I'm not too good to make that mistake, right? But make sure you multiply the factor that you choose by everything. Everything gets this 3. All right. So now, and this is why it's also called the addition method, because I'm going to add this to this, this to this, this to this. What's x plus 12x? 13x. 1x plus 12x is 13x. You got 13 x's all together. You got one of them and 12 of them. One of them, 12 of them. What's positive 3 and negative 3? They cancel out. Nothing. They become 0. Then over here, we got 8 plus 18. That's 26. Now we got 13x equals 26. Now we got one equation with one variable. That's why we eliminated the y's. So we would have one equation with one variable. We could have eliminated the x's. And then we'd have one equation with just y in it. And we solve for y first. It don't make a difference for real. Like for real, it don't make a difference which variable you decide to solve for. All right. So we got 13x equals 26. Now I want to isolate x. So I want to get rid of 13. How do I get rid of 13? By doing the opposite operation, which is division. Divide by 13, keep it balanced. Divide by 13 on the left, divide by 13 on the right. 13 divided by 13 is 1. So I got 1x, which is just x. Now x is by itself. Now, make sure you know your division facts. Before that, make sure you know your multiplication facts. Because if you know your multiplication facts, then you'll inherently know your division facts. If you know that 13 times 2 is 26, then you're going to know that 26 divided by 13 is also equal to 2. So x equals 2. We're not done though. Remember, this is a system. There are 2 variables, x and y. We're only halfway done. Now the question is, how do we solve for y? Go back to the original system. Pick either equation. Does it matter which one? No, it don't matter. Pick whichever one you want. You want to use the first one? Use it. You want to use the second one? Use that. Right? I'm going to use the first one. And this is what I do. Since now I know what x is, I don't need to use the variable x because I know what x is. What's x? X is 2. I only need variables when I don't know what the variable stands for. Right? When I don't know what they represent. I know what it represents. It represented a 2. So when I rewrite this, 2 plus 3y equals 8. Now I'm solving for y. Now I got one equation with one variable. That's the goal. You try to get the one equation with one variable. That's what you want. You want one equation with one variable. So we got 2 plus 3y equals 8. I'm trying to get y by itself. So I got to get rid of the 2 and get rid of the 3. Some of y'all might be wondering, what do I get rid of first? Technically, it don't matter, but I'm going to put you onto this, right? Most of the time, like 90% of the time, well, I ain't going to say 90% of the time, but most of the time, if you get rid of the coefficient first, the equation is going to start looking crazy unnecessarily, right? Because you would have to divide this by 3, divide this by 3, divide this by 3. That's going to create a fraction because you're going to have 2/3. That's going to create an improper fraction. You're going to have 8/3. You don't need to do that unless it's absolutely necessary. It ain't necessary. If you get rid of the constant first, most of the time, the equation will come out a little neater. Not all the time. Not all the time. But most of the time. Like right now, watch this. Right? If I get rid of the 2, this is a positive 2. The opposite of a positive 2 is a negative 2. That means I'm going to subtract 2 on the left side. I'm going to subtract 2 on the right side. 2 minus 2 is 0. Bring that 3y down. Now we got 3y equals 6. No fractions. And I like fractions. A lot of people don't like fractions. I like fractions, but fractions do get in the way sometimes because they require more work in order to handle and do computation with. So now I got 3y equals 6. Now I'm trying to get y by itself, so I got to get rid of that 3. How do you get rid of the 3? Opposite operation. What's the opposite of multiplication? 3y means 3 times y. 3y means 3 times y. What's the opposite of multiplication? Not addition, not subtraction. It's division. It's division. Divide by 3. Divide by 3. 3 divided by 3 is 1. 1y is just y. 6 divided by 3 is 2. So look, x was 2 and y was 2. That's a coincidence. Don't think that just because you get the same number that you did something wrong. You could have, but that don't necessarily mean you did something wrong. But that's why you always go back and check your work. Always go back and plug them numbers in to see if it gives you a true statement. The purpose of math is to figure out the truth. We want to figure out the truth when we do math. Now, is this a true statement? Is 2 plus 6, where I get 6 from? 3 times 2. Y is 2. If y is 2, 3y means 3 times 2. That's 6. Is 2 plus 6 equal to 8? Yes, it is. It's true for the first equation. But remember, this is a system. These variable values got to work for both equations. All right? So now we got 4 times 2, which is 8, minus 2, which is 8 minus 2 equal to 6? Yes, it is. It works for the system. All right? It's a system, right? Systems are very strong, right? Systems are very cohesive. They work together, right? Just like our ancestors down in Saint Domingue in 1791 decided they wanted to overthrow the system of chattel slavery, right? The French was getting too much money off the sugar plantations, right? So a lot of us to this day, when we want to go to the south of France and be inwards in Paris and all that type stuff, a lot of that goes back to all the money that the French was getting from our ancestors, from the sugar plantations. Think about that. Keep in mind the connections. Everything is connected. Everything is interconnected. Everything has historical relevance. All right. So our ancestors wanted to overthrow the system of chattel slavery. And they were successful to an extent. To an extent. But I'm going to let you study that. All right. So we got x equals 2, y equals 2. This is how you solve a system of equations using the elimination method. The elimination method. This is not the substitution method. This is not the graphing method. This is not using matrices through Kramer's rule or whatever. This is the elimination method. Some textbooks call it the addition method. All right. So that's that. All right. Once again, Sock Passe. Happy Haitian Independence Day. I'll see y'all on the next video.